Hello guys, so this is the last little bit in section 1.3 that we have to talk about. We just have to talk about this very last objective, evaluate piecewise functions. Hopefully piecewise functions sound familiar to you. If not, let's start talking about them, okay? So piecewise functions are super applicable to the real world. So notice a lot of times this is what happens. It says a telephone company offers the following plan. $20 per month by 60 minutes, right? But anything after those 60 minutes is an additional cost, right? So then it's going to change. So this is what happens. Here's your definition. Piecewise functions are a function that is defined by two or more equations. So right here would be an equation, and here would be an equation. And notice they both have to be specified over a specific domain. We just talked about that vocab word, domain, x value, okay? And that's what we can take a look at. Let's zoom in here real good and let me break down this, equate this for you. So it says, okay, maybe I'm not zooming in real good. It says there's two parts, right? And the two parts are right here. The first part gives you the equations, okay? The two equations. 20 is an equation, and then 20 plus 0.4 times t minus 60 is your second equation. And then the second half of this, notice it says if, look, there is your interval notation. Here is your domains, okay? But then, so that's like the two sections of this, but then this is about to get real crazy in here because this domain fits with this equation and this domain fits with this equation. So every equation has a specific domain. And notice it makes sense. It says it's at 20 from 0 to 60. So here's 20, and from 0 to 60, notice I'm at 20. 0 to 60 on my x-axis. And then everything after that, I have a new equation, a new line from 60, anytime after 60, greater than 60. Just like there, there's my new part. Okay, so two different functions are on the same graph, and we need to be able to evaluate it. So notice here's that same equation, and now I want to evaluate c of 30. Notice instead of f of x, it's just c of t, no big deal. Okay, and how we figure out, because there's two equations here, right? There's 20 and then 20 plus 0.4 times t minus 60. How do I know which one to plug this 30 into? And how do I know which one to use the 100? We follow the domain. So as soon as I see what number I need to evaluate at, I go right to my domain and ask myself, is 30 between 0 and 60, or is 30 greater than 60? It's this first one, right? So that's how I know I'm using that first equation. Now that equation doesn't have any x value or t value, right? So that's my answer, my y value. It's c of 30 equals 20. So now I do b, right? I want to do c of 100. So 100, does that fit into the first domain or the second domain? And we know 100 is greater than 60. So this is the equation that we're going to use to evaluate c of 100. Just like we practiced in the last section, I take that 100 and substitute it in for t, in for the variable, and then we simplify. I'll do 100 minus 60, gives me 40. 40 times 0.4, 16. Simplify that, and I get 36. Okay? So how do we know which equation to use? It's all based on the domain. So always look for your domain and check that first to then tell you which equation to use. Okay? Any questions on this video or any questions on the last video that talks about the other objectives, bring them to our class and I would love to discuss them with you guys. Great work.